Hello everyone, this is S. Roy. Let's start the day 2 material following the textbook in that Scala chapter. Okay, let's proceed. First, we'll talk about some additional object-oriented features which is available in Scala, and of course polymorphism should be supported, right? So let's see what I have. First, an example about polymorphism. Say there is one animal class, and that class has an attribute for the age of the animal, and the class also has one function or method, if you want to call it method, that name is make sound. So this method is supposed to produce what sound this animal makes. But if you think a little more, you understand that different animals make different sounds. Like human make talk sound, and dog makes barking sound, right? So before knowing which sort of animal we are talking about, it is impossible to implement the body of this function, make sound, right? So that's why make sound is an abstract function, and this class animal should be also an abstract class, but we can inherit from this abstract class, and we can have a human class, and also we can have a dog class, and those human class and dog class can be concrete. So what this human class has, it has an additional attribute leg, and human has two legs. And in addition to that, human class also implements this make sound, and the implementation is making talking sound. And on the other hand, dog class has leg equal 4, and it also implements the corresponding make sound with barking sound, right? Now let's see how we can use these human class and dog class to make some realistic example. So this is the whole code. First, this trait animal represents its abstract class, where age attribute is 0 by default, and we see make sound doesn't have a body. Then human class is extending from animal, right? And that constructor accepts age information and populates the age attribute with that age information, and it also creates two legs for the human class. Also overrides the method in the parent trait, make sound, and here it is concrete body talk. Similarly, dog class overrides the same method with concrete body bark, correct? Now let's do an exercise. Let's create a list of animals. First, first initialize the list. In Scala, nil means a list which has no element. So first the list is nil. Then get a random variable. It's basically an utility available in Scala library. So get random class, and then run a for loop which can iterate maybe 10 times to create 10 animals. And let's see what happens in each iteration of the for loop. We get a random integer between 0 and 1. So if you say next this random dot next into, it will create an integer which is either 0 or 1, so that is less than 2, either 0 or 1. So those are the two possibilities for this random integer x. And if x is 0, then we create a human with a random float as the age of the human, and we append. So this is the lists append operator colon plus. We append that newly created human object with the existing list. Similarly, if x is 1, that is the else situation, we create a dog and we append dog with the list. Makes sense, right? So how 10 animals will be created in this 10 iterations of this for loop, and we'll have a list of 10 animals at this end, right? Then we can traverse this list from the beginning to the end, and we can call make sound function on each animal in the list. Now think about it. When we are writing this code, we do not yet know in which sequence the animals will be created in the list, because this is random, right? That happens only in runtime. When we are coding, we do not know that information, correct? So there is no way from the code we can call the corresponding make sound from the code. There is no way, right? The polymorphism concept does the magic. So when we just call x dot make sound, where x is the generic animal. Why I say so? Because this list was a generic animal, right? And x is one element in that list. So this make sound is basically referring to this generic situation, but Scala in runtime can figure out whether that animal is human. If it is human, it will invoke the corresponding make sound talk, otherwise bark. And that concept is called polymorphism, right? To decide what the specific type of the object in runtime, right? Another alternative also is available. We can have this abstract class animal, and then we can extend human from animal. Other code is similar, dog extending from animal, right? And then we can create one human and one dog. Just for an example, we are creating 2 animals. We can create 10 like before in the previous example, but with 2 also we can do the similar thing to show things. So then an list is initialized, and we concatenate the human with the list, concatenate this dog with the list. So at this point we have 2 animals, right, in the list. Then we can traverse this list with for each, and the difference here is this case keyword. So using the case keyword, we can check what is the type of x in runtime. If the type of x is human, then if we say x dot make sound, automatically Scala can figure out that this should be called. Otherwise, if x type is dog, then in runtime Scala can figure out this should be called, right? So you can see that with another style we can achieve similar polymorphism effect, right? Okay. Then let's talk about more higher order functions which are available in Scala. We have seen some basic higher order functions before. Now let's see some additional higher order functions in Scala. Exists is one of them, for all is another one, sort is another one. These are examples of higher order functions. Let's take an example. Let's create a words, which is a list of these words, and then we can use this for all higher order function on this list. And what it does, given a constraint which is an anonymous function, that given a word we want to check whether that size of the word is greater than 1 or not. So this constraint can be applied to each item in the list, and if each item in the list satisfies the constraint, then for all will return true. So in this case, each word is size each word has size greater than 1. So in this particular example, this constraint, this anonymous function is satisfied on each item in this list. So for all will return true. On the other hand, if we use exists, this higher order function, and another anonymous function as a constraint, then this higher order function exists just check, is there at least one item in the collection which satisfies this constraint. Just one item being in the collection which satisfies this constraint is enough for exist to return true. And you can see the difference from for all, right? It's kind of complementary. So in this case, there is one word whose size is greater than 4. So in this case, exist should return true. But if we change the constraint to word size greater than 5, there is no such word whose size is greater than 5. So in this case, the exist will return false. We have more higher order functions, sort with, that can sort the elements in the collection. So here words is the list, sorts with can sort the elements in this collection. Now we can provide the sorting criteria, the comparison operation which the sort use. Remember what a sorting algorithm does. Sorting algorithm should know from the user that how to compare two items, right? Because sorting algorithm needs to know, given two items, which one should be placed before and which one after, right? So sorting algorithm really expects a comparison operation from the user. And this syntax allows the user to provide the comparison operation as the anonymous function. So here its anonymous function says, given two item, this is the criteria to sort them. And if the size is less for item S, then that should be appearing first compared to the other item T. So this is the criteria which this sort algorithm will use to sort these all items, right? So the output of this will be AL should be placed first after this sorting happens, because that's how that size is the least. Another way of doing the same thing is sort by, and here the anonymous function just says sort by size. Okay, now it's time to do some exercise. So here we have the same list, and now if we if we provide the constraint like this, that X is one item and we want to check whether the head of that item is greater than A or not. And remember, when we say a character is greater than character A, that means this character should be appearing after A in dictionary, right? So that means B, C, D, they are greater than A according to the ASCII value, right? So here we the constraint basically says whether all items starts with a letter, because that item dot head means the starting letter. If the starting letter is greater than A, that means the starting letter should be either B, C, D. But we see here there is one item which starts with A, so here the for all should fail, right? So this should return false. Now if we use exist, and this is the constraint, so we are checking whether there is any item here in this list whose head is greater than C. As an example, this one, right? Or this one, their head is greater than C. So there is one item in this list for which this condition is satisfied. So exist, this higher order function should return true. Now let's take more examples. Sequence is another collection in Scala, and you can have, say, these three items in sequence, and then you can use this higher order function filter, and you can provide an anonymous function as the filtering constraint. So first, let me copy this code. Maybe let me go to my Scala system so that I can explain few things, and let me paste it here. So this is the sequence, right? Now if you remember, what was our next line is this one. So we are trying to filter with some constraint. This is a shortcut constraint. First I will explain with the extended version of the same constraint. The extended version is this one, and that may make more sense, right? So the anonymous function is, given an item, I want to check whether the length of the item is greater than 2 or not, right? So this is my constraint, this is the anonymous function, and filter, this higher order function will apply this anonymous function to each item in the list, right? To hello, and for hello that size length is greater than 2, so that is satisfied. But for 2 the length is not greater than 2, so this is not satisfied. So filter will filter this word out in the output, right? So you can see that the output of this operation doesn't have this word 2, but u will be there because the size is 3. Now coming back to the previous point, this extended version of writing the constraint is exactly same as writing it this way. So this underscore basically means that whatever was x, that place should be occupied by x. Make sense? Okay, so this is just a shortcut way of writing the constraint, or writing that this anonymous function. Now let's come back. We have more. So array is another collection. Say we have 4 items here, and here we are filtering with this constraint whether length is greater than 3. And now you understand that this is not with size greater than 3, this is not size greater than 3, so this 2 should be filtered out, right? And yeah, we do not show that output. Okay, another example, this is a sequence where we have these 2 words, hello and world, and now map is an higher order function, and that can apply the given anonymous function on each item. Here this is also a shortcut way of writing that anonymous function. So this one also, let me explain. Let me copy this one, come here, and then we say s.map, and that was the shortcut. You can see that each item is getting reversed. The extended version is x goes to the extended version is x goes to x dot reverse, right? So this is the anonymous function which map will apply to each item in the collection. So first this anonymous function will be applied to this item, correct, and then to this item, and then those 2 outputs will be collected together and will be returned as a final output, right? So S has these 2 items, and the output is reverse of the first one and reverse of the second one, and these 2 things together as a list is the output of this map operation, right? So remember, map is a very important higher order function, and ultimately it returns the collection of all the outputs together as a list, or as the same type of the original collection. Okay, now another example we have here, which is there is a set of 4 numbers, and we can use map to multiply 4 with each of them, and this again is a shortcut way, of writing that anonymous function, which you can write as extended form also. Now, another higher order function to learn is fold left, which is very similar to the inject method, which we saw in Ruby. Here is an example. Say list has this 3 item 3 to 5, and we want to aggregate all these items. So we can write fold left, initial value 0, and this is the anonymous function which does this operation that sum is first initialized with 0 because we provided 0 here, and then this item is each and every item coming from this list, and this is the operation which will be applied in each iteration. So first sum is 0, item is 3, so we make this addition, so sum becomes 3 next time, and then item is 2, so then 3 plus 2 5, and so on. So this sort of aggregation will happen again and again, and ultimately the total aggregate result will be returned. That is the concept of fold left. So it is basically folding things starting from left in the collection. That is the concept. Another example, so not only numbers we can fold, we can also fold strings. So here in this collection we have 4 strings. If you say fold left starting with 1 as the result and concatenation operation, plus for string means concatenation, so it will start with 1 these strings and then concatenate all other items in the list together. So ultimate result will be 1 2 3 4 5. Okay,